My name is Joseph Williams, and this is my presentation for my term project. So here's an outline of what I'll be covering today. I'm going to start with a brief demo of the functionality of the application. Then I'll go over the overall design, the overall design big picture, and then after that I'll dive into the specific details of the 3 design patterns I use for this project, and then finally I'll review the actual implementation code. So this project consists of 2 main parts. You have the front end, that's a React application called route mining, and then you have the back end application that actually validates the data, creates the reports, and that application is a Node.js/Express web service application. So here's the input file, the Excel formatted input file that contains the list of addresses that are submitted to the backend portion of the application. So the first two rows in this file represent the main address for the U of M Dearborn campus. So the word evergreen is misspelled in both cases, and this is to check the ability of the application to validate data, or to validate different address parameters. So in the first case, it should be able to compare this row with the data in the USPS database and determine that what the user meant was the actual address of the U of M Dearborn campus, and update this information accordingly. And then the second row, because so much information is missing, the application won't be able to validate it. So this data won't be used to search for carrier routes, and it'll simply result in an error. And then the last 2 addresses are apartments that have the same carrier route. So they should show up on the carrier route report. The carrier route report should include 2 addresses for whatever carrier route number corresponds to this apartment complex. And so here's the React front end for this project, and if you click the Get Input button, it simply displays the same input data from the Excel document we just looked at in table form. So that's what's shown here. And then if you select the Get Output button, this actually causes the backend to perform the different responsibilities of the application. So it calls the USPS database to attempt to validate the addresses from the list of addresses, and then it corrects any address it's able to validate, and then it uses those valid addresses to as input to the part of the application that that calls the USPS database again to check for the carrier routes for those valid addresses. So below the input table, you have your report tables that show the results when the application is actually run with the input data. So For the first address, it was able to correct the data, correct the spelling of Evergreen, and then add the correct city and state for the school. And then for the second address, because so much information was missing, it wasn't able to come up with a match. So as a result, there's no carrier route or any updated data. It's simply blank for that address. And then for the final two, since these addresses correspond to apartments in the same apartment complex, they have the same carrier route. And then for the second report, we're showing the data for the carrier routes. So the first carrier route has one address, and that corresponds with the address of the U of M Dearborn main campus, and then the two apartment complex addresses, because they have the same carrier route, are mapped to that carrier route in the carrier route data report. And so this is the output of the route mining application. And then also the application created two additional Excel documents. So you have report 1 and report 2, and these simply correspond to the table data that the front-end application is showing. So you have the same information, it's just formatted slightly differently, and so the user can work with it in Excel format if necessary. So here's your report 1, and it just contains your addresses with your validated addresses with the carrier routes, just like we saw on the web interface. And then report 2 should look the same as well. It should just have the carrier route data, and here's the same carrier route data that we saw in the web user interface. So that's that pretty much covers the basic functionality of the route mining application. And so in terms of overall design, I broke the project into 5 steps. So for the first step, the application needs to extract data from the input Excel document and save that in some kind of data structure. So after that information is extracted from the input document, it then needs to validate those addresses and correct them if possible, and then take the validated addresses and attach carrier routes to them. After the addresses have been updated with carrier routes, the application needs to organize the data. Organize the data into 2 formats: one for report 1 and another for report 2, and then that formatted data is finally used to create the 2 Excel reports that correspond to that formatted data. And so here's the UML class diagram that represents how the different design patterns were used to create the back-end portion of this project. So on the far left-hand side, I'm using the decorator pattern to validate the addresses and to attach the carrier routes. And then in the middle, the blue classes correspond to the builder pattern, and I'm using that to create the 2 different versions of the report object. And then finally, the facade pattern is used to create the actual Excel documents that contain the resulting output data from the application. All right, so here's a close-up of the decorator pattern. And in terms of my reasoning, if you look at the lecture slides, the lecture slides from the design pattern course, in terms of the decorator pattern, it talks about adding additional responsibilities dynamically by wrapping an object in a decorator object. So the example given from the lecture slides, at least one of the examples given from the lecture slides was the coffee example, where you could dynamically add additional ingredients to your coffee, and then that would automatically update the cost associated with that cup of coffee. So I'm sort of following the same philosophy, but instead of updating the cost of the object, I'm using the validation decorator to validate the contents of the address object, and then update them if possible, and then also the carrier route decorator to update the contents of the address object with the corresponding carrier routes. So that's how I incorporated the decorator pattern into this project. And then so here's a close-up of the builder pattern. And going back to the lecture slides, they talk, in terms of the builder pattern, they talk about being able to use the same construction process for different representations, and that works here because I need two different representations of the same the same report object. So I need an address report and a carrier route report, and so the data so the data is represented differently in each report, and the client is able to conveniently use the director class to create the two different reports using the same process. And so that's why I chose the builder design pattern, because the client needs to build multiple objects, multiple types of the same object, the same report object. And then finally, the facade pattern is used to sort of as was mentioned in the lecture slides, to simplify the user interface. So in the case of this application, the user interface I'm trying to simplify is the interface for creating actual Excel documents. So instead of the client needing to know the details of the libraries that are the details of the library that's used to create the Excel document, or all the details of the report object, I'm sort of adding a layer of abstraction over that, and instead they can just pass their reports into the facade constructor, and then use the two create output methods to create the corresponding actual Excel documents. So that's how. So those are my three design patterns, and like a brief overview of the reasoning I used when I was choosing to incorporate them into this project. And finally, let's take a look at the actual implementation code. And so here's the overall design. Here's the overall UML class diagram for this project, and then this is here's the front end. This is just a this is just the React code that was used to create that single page application. It's pretty similar to HTML, and it's pretty simple. And so I'm not going to get into the details of this portion of the code. I actually implemented all of the design patterns on the back end. So essentially um, the essentially the React application is just creates a simplified user interface, um, and so it's just, as you saw, it's just a couple of buttons and a few tables that represent what's actually going on in the back end. And in terms of the back end, um, so okay, so this is the code that's used to actually extract the data from the input file and save the input addresses in an array that consists of address objects. And then in terms of the actual design patterns, because this is a Node.js application and I'm using JavaScript, I needed to use the TypeScript language, which is sort of a superset of JavaScript that actually allows you actually incorporates some of the constructs of typical object-oriented languages. So vanilla JavaScript doesn't let you declare abstract classes, and it doesn't have the same kind of typing system that that languages like Java or Python have. So I needed to use TypeScript for this project to actually build the design patterns correctly. And then and so one thing to keep in mind if you end up running this project, the the TypeScript file is extension TS, and it has to actually be compiled into JavaScript before it's run with the application, because the TypeScript doesn't run directly. So this is this TSC command is the command that's used to compile the TypeScript into JavaScript, and then this resulting JS file is what's actually run with the project. But the initial TypeScript file is how I implemented the design patterns. And so starting from the top of the file, you have your abstract class, your abstract address class that sort of creates the interface for your addresses, and then you have your address class that inherits from your abstract address, and after that you have your abstract address decorator and your two decorators that inherit from the abstract decorator class. And so these four classes, or these five classes, this is essentially the decorator pattern that was used. And so your abstract decorator creates your decorator interface, and then then the validation decorator is what's used to validate the addresses, and likewise the carrier out decorator is the class that's used. Is the class that wraps an address and adds carrier routes if possible. It actually so the decorator classes are the classes that actually interact with the USPS data to figure out if your inputs correspond to valid addresses. And then and so in the middle, the blue classes represent the builder pattern, I'm using for this project, and so here are the builder classes. You have your abstract report builder, and then the specific address report and carrier route reports that are used to structure the data for the two different types of output reports, and they both use the report class to they both create report objects structured differently, and then the client actually builds them using the director class. And so that's the builder portion of the project. And then finally, on the far right is the facade part that's used to create the Excel document. So as you can see, the facade pattern is hiding quite a bit of complexity from the user, and sort of streamlining the report creation process by adding a layer of abstraction. And so your create output Excel 1 and create output Excel 2 are the two methods on the facade objects that are used to create your reports. And the facade class uses a third-party Excel library, and then the report class to create those Excel documents. And then finally, this file is the main Node.js Express web backend part of the application, where the routes are implemented. So the get input and get output routes correspond with the get input and get output buttons on the front end, and that's what's called by the front end when these buttons are pushed. And so for the get input, you're simply using the data reader utility function to pull in the data and then send it back to the user interface. And then for the get output endpoint, this is where the actual design patterns are implemented, or they're actually, or I should say, this is where the design patterns are actually used. So so first, after you receive the array of address data from the input file, from the input Excel document, each address is wrapped with the validation decorator object, and then after that those validated addresses are wrapped with the carrier route decorator, and the carrier routes are added, and then the resulting wrapped addresses are put in an array called output array. And this array is passed to the report writer objects construct report function. So this is the builder pattern. So this is how the builder pattern is used to create the address report and the carrier report through that through the director report writer object. And then after those reports are after the reports are constructed, they're created with the get report methods, and then that data is used, and then that data is finally passed into the facade constructor, and the facade pattern is used as a very simple interface to create the two output Excel documents. So it creates these two output files, and then that report data is sent as a response to the user when they select this, when they call this get output endpoint. And yeah, so I think that pretty much covers my application code and how it corresponds to the design patterns I chose to use. I guess one final thing to note is the client application is, when I say client application, I'm essentially referring to this get output endpoint in the carrier route file of the backend portion of this project. So that's the client part. Anyway, that pretty much covers everything. Thank you.